Hello, all of you beautiful people. Welcome to Geometry Mondays. Is it Monday? Yeah, yes, it's Monday. I don't know, man. The days, they're just all running together. All right, Corona, thanks a lot. Anyways, 11.4, we're talking about the area of a kite. So let's build the area of a kite before I give you the formula, which I guess you could already see, but anyways. So we have a kite, right? And the things that you know about a kite are the disjoint sides are congruent, which means these two sides here are congruent. These two sides are congruent. And a kite has two diagonals. I'll call this diagonal D1. I'll call this diagonal D2. Now, a special property of a kite is that the diagonals are perpendicular to each other. And that's going to be important for us to build this area of a kite. Anyways, notice this triangle here, like diagonal D1 divides the kite into two triangles, top and bottom. And I've separated them for you so you can see a little more clearly. Let's call the area of this little triangle, let's call it A1. Now the area of any triangle is 1/2 the base times height. And so the base here of this triangle is just D1, is it not? And so 1/2 D1 times the height, I'll call it H. H is just a part of D2, right? And I'll just call it H because I don't know what it is. And now this second triangle here, it shares D1 as a base, just like this triangle. And I'll call the area of this triangle A2. Okay, so the area of a triangle is 1/2 the base times the height. Well, the base is D1, so 1/2 D1 times the height here. So the reason why it's important to know that the diagonals of a kite are perpendicular to each other is because this value wouldn't be the height if it wasn't perpendicular. So anyways, I've got 1/2 base here, which is D1, times the height. Now if I called this H and the whole diagonal is D2, then this piece is going to be D2 minus H, which means that the area is 1/2 times D1 times D2 minus H. And now the area in general for this kite, or any kite, is just A1, the area of that triangle, plus the area of the other triangle. You agree? And so I'm just going to replace the values of A1 and A2 that I figured out. A1, 1/2 D1 times H. A2, 1/2 D1 times D2 minus H. Notice they have these half times D1s in common. And so I'm going to factor out a 1/2 times D1. And what I'm left with here is H plus D2 minus H. Now notice, H minus H is just 0. And so this simplifies into 1/2 diagonal 1 times diagonal 2, which is the area of a kite. It's just 1/2 the product of the diagonals. And so you're going to use that in problems. They're going to be different types of problems. They will be challenging. Some of them will involve properties that you need to know. But I just want to do one example problem for you. Find the area of a rhombus. Wait, what? I thought we were talking about kites. I know. Well, a rhombus, because all sides are congruent, right? A rhombus is a kite because the disjoint sides are congruent and the diagonals of a rhombus are perpendicular, which means a rhombus is a kite. A rhombus is also a parallelogram. And so we could use the area of a parallelogram to find the rhombus, but we would need to know the height of this rhombus to do so. We would need to know the height. So remember, the area of a parallelogram is base times height. Well, let's see what we have then. It's a kite. Rhombus is a kite, but it's also a parallelogram. Okay. Okay, hey, that's parallelogram. Okay. Anyways, what do we know? We know the perimeter is 20. If the perimeter is 20, and all these sides are congruent, that means each one of the sides is 5. You agree? What else? The longer diagonal is 8. So I just called this longer diagonal D1. It's 8, right? A property of a rhombus is that the diagonals bisect each other, which means if this total here is 8, then this little piece here is 4. And what we have here is a triangle that's a right triangle looks like it's a 3, 4, 5 to me, which means that this little side here is 3. Diagonals bisect each other. This would also be 3, which means I have all the information I need to find the area for a kite. I can't really find, I mean, I guess you could, but you don't want to go that route. So I know the area of a kite, equals 1/2 D1, D1's 8, times D2. What's D2? Well, I had to figure out what D2 was. It's 3 plus 3, which is 6. Half of 8 is 4. 4 times 6 is 24. So the area of this kite here, or rhombus, is 24 units squared. Thank you. You'll find the homework attached to the assignment. Okay, see ya.